Hi everybody, it's Miss Ross here. So we're going to do things a little bit differently today in the sense that we're going to be exploring energy sources, but from the convenience of your own home. So sit back, relax, and remember you have a worksheet to fill out. It's a little table as we go along. So let's talk about generating electricity. Even though we did go over today in class how we get energy into our homes, we're going to go back in history a little bit to 1831 to see that Michael Faraday actually might have come up with the first solution of how to get the energy from one place to another. So what he saw was that an electric current can be generated by moving a conducting wire through a magnetic field. And this is called electromagnetic induction. Okay, great. Now, what does this have to do with electricity today? Well, large-scale generators that many of the cities use, they are actually electromagnetic induction just on a larger scale. So what happens is these generators, they transform energy into electric current. So each generator has magnets inside of it that are rotated by a turbine. Okay, and those magnets, they take copper wire and they spin it, and it's that spinning motion that creates the current inside the generator. And from that, when we have the current made in the generator from the spinning, we can then send it through transmission lines into the cities and towns. And that's through those big power lines that you see. Although we know how we get energy into our homes, today we'll be exploring actually those sources of what powers those generators to get us that energy. So let's take a look at this video for starters. Perfect. So hopefully you all had a chance to see that. Now, how do we get this energy? So we're going to explore a few sources. The first category we're actually going to explore is probably the most prevalent category, and that's using the power of flowing water to generate electricity. And that is a fancy word called hydroelectricity. So hydroelectricity, because it's using water, it's considered a renewable resource. So what happens is that the water is continuously flowing and it won't run out. So this is a resource that we can depend on over and over again. Now, just a note, if you're having trouble with the terms renewable and non-renewable resource, please turn to 474 in your textbook and copy down those two definitions for your notes. So how does this work? Well, these waterfalls are used to turn the turbines inside the generator so that as soon as the water power hits the turbine, it can get that generator to create the current. So as you can probably hypothesize right now, you're probably thinking right about Niagara Falls. And it's true, Niagara Falls actually is one of the largest hydroelectric stations that powers that city of Niagara and even can go into different towns and cities. But what happens if a city doesn't have a waterfall? So what the city can do is, if they have a river, they can build a dam like this one over here. So what happens is you'll have water stored in a reservoir, and then it flows through these channels over here. And that's called a penstock. You can probably see it a little bit better here. As the water flows through the penstock, the channel, it's coming at a good enough speed to spin that turbine and power the generator. And from there, the generator creates that current and it can travel through power lines. You could probably take a look and see it better over here. As the water is flowing, turbine is spinning, generator is powered, and boom, electricity. So hydroelectricity is one of the main sources, but unfortunately, the amount of electricity that we need in Ontario and Canada in general is not enough to just use the hydropower. So we can use another category, and that's heat. However, if we don't have water to power the turbine, what force could we use to spin that turbine? The answer is steam. And how do we get that steam to power the turbine? Well, first thing we're going to do is we're going to burn fossil fuels. So fossil fuels are fuels such as coal, oil, and natural gas that act as that burning fuel for the generator. So we burn the fossil fuels, they create steam, the steam powers the turbine and creates that current. So the term fossil fuels means that it comes from organic matter that lived millions and millions of years ago. So that acts as the fuel. However, one thing to note about fossil fuels is, as you probably know, they're a non-renewable resource. Once we use them up, we can't get them back. Okay, so aside from fossil fuels, we can also create steam to power the turbine by using biomass as the fuel. And what this is essentially plant and animal waste, things like wood and pulp for paper and other things listed there. And we can use that to power the turbine and to make the fuel and make what is required for the generator to create our energy. Biomass, on the other hand, is a renewable resource because it's organic waste, so it's easy for us to get from our environment. So how this works is this organic waste decomposes and it creates something called methane gas. This gas can then be burned to boil water and create that steam. Remember, it's that steam that we need to turn the turbine. Yet another, as you can see the heat's pretty popular, is nuclear energy. So Ontario itself requires a huge amount of electricity. We do have a large population and we have a huge manufacturing industry. So hydroelectricity and thermal electricity, so that's fossil fuels and biomass, just doesn't cut it for us. We need more. That's why a large percentage is nuclear energy. So we like to use atoms of heavy elements such as uranium. Think back to chemistry, properties of uranium. This is pretty much obviously a non-renewable resource. Once the uranium resource runs out, unfortunately, we're going to have to turn to something else. So how does this work? What we do is we use a process called nuclear fission, and that's just basically the splitting of uranium. So we're going to split it into its different pieces and contents. This actually releases a tremendous amount of energy, and guess what we can do with the energy? Use it to heat the water, make the steam, and turn the turbines. You can see a similar example. All the different energy sources follow the same pathway. They just